had 14 dividers up.
Yeah.
Okay.
So like this.
So everybody's got these out in front of them. We are going ahead and starting our next unit. So we're moving on from writing those equations. We're moving on to unit 2, which is going to be about our exponents.
Thank God.
Oops. Okay. All right. So here at the top of the page, it says to expand each expression. So when they say expand, they just want us to write down what it literally means to have an exponent of 3 or 4 or 2 or 6. So what does it mean to have t to the third power? What does that 3 mean?
3 times 3.
Times itself, how many times? 3 times. So if I have t to the third, that literally means t times t times t. Okay? Nope, that's not 3t, not the same. All right, then it says times t to the fourth. What does t to the fourth mean?
T times T times T times T. That's a lot of T.
All right, so here, how many t's do we have altogether if you count them up? 7. So I would have t to the 7. Okay, let's come over here. Let's expand this one.
Wouldn't it be 1?
T to the 7th. There is 1, 2, 3, 4, 5, 6, 7 t's. So it is t to the 7th.
So it'd be 1.
No.
T to the 7th power.
Oh, I.
All right, number 2 says we've got 5s squared. So the only thing with the square is the s, right? The 5 is not being raised to the 2nd power. So I have that 5. What does s squared mean?
S times it.
S times s. So I've got 5s times s. Okay, times,
6S times S times S. I can't count.
Right. 1, 2, 3, 4, 5, 6. So this one had 6 in front of it, so I copied down that 6, and then it had s to the 6, so I had 6 s's, right?
Wait, so why would we multiply the 5?
We're about to do that. So now it's time to multiply. So we would multiply the 5 and the 6, right? Those are numbers. We know how to multiply numbers. 5
30.
times 6 would be,
30.
yes, 30.
Uh,
And how many s's do we have all together? 8. So this would be 30 s to the 8th. All right, so what did we do to come up with this 8 here and this 7 here?
counted all the exponents.
Counted them all up, right? Added them
Not
all
the
up.
exponent.
Yeah.
All the numbers.
All the letters, yes. So that should lead us to our first rule of exponents. It says here, properties for exponents. To multiply powers with the same base, which is what we had here, right? The base was t both times, right? We just added the exponents. 3 here, 4 here, for a total of 7. That way we don't have to write it all out every time. We now know the rule is just add your exponents. So here, it says this works for any non-zero base. So as long as your base is a t or an s or an x or a number, as long as it's not 0, you can use that rule, where you add the 2 exponents to get your final answer. So now that we have that rule, here x squared times x cubed would be x what? Very good. And how did we get that 5? We just add the exponents. So instead of writing it all out, we just added our 2 plus 3 to give us that exponent of 5.
Man, you made us write.
This way you don't have to write it all out like we did up at the top every single time, because that would get annoying, especially when the numbers are really big, right?
Would it be the same? What I said about the power of 5, is that correct? Like of me saying?
Yes.
You correct?
Yes. You can say the 5th power or the power of 5. It means the same thing. All right, on example number 3 right here, what's my base? It's the 2, right? So I keep my 2, And what am I going to do with those exponents of 3 and 5? Add them. And what do we get? 8. Now, in this particular case, this is a number, so you actually could raise 2 to the 8th power if you wanted to. But we're just practicing our laws of exponents right now. All right, number 4. I've got these two numbers that don't have an exponent with them. What am I going to do with that 2 and 3? Multiply them, just like we did up above, right? Big numbers, we use our normal rules. 2 times 3 literally means 2 times 3, which is 6. Okay, and then my base for my exponent is n. What do I do with the exponents? That's what we add. Okay, so I would have n to the 9. Yes.
On number 3, when if there's no letter after it, you just have these. You don't, so it would be 4 to the 8.
Right, right.
But if there's the letters,
It's the thing that's being raised to the exponent. That's what you. So like here, the 2 and the 3 didn't have an exponent, right? So I multiplied them together. Yep.
Why didn't number 3 belong to 40?
Because we're taking care of the exponents. Here, does 2 have an exponent? It does. I don't see an exponent with the 2.
Oh, no.
Right? That's why we multiply, no exponents. Okay. So whenever you are using your adding rule, it has to be something that has one of these exponents up here. Okay. But this 2 and this 3 did not have an exponent, so I multiply them like normal. Okay? All right. Let's look here at number 5. Okay, does this 14 have an exponent?
yeah.
No, no exponent.
No.
Where does it have a tiny number beside 14? The x has an exponent. Does 14 have an exponent? No. Okay. What about the 2? Does the 2 have an exponent? No. So what should I do with the 14 and the 2? Multiply. And what is 14 times 2? 28. All right. Now remember, we said our rule only works for things with the same base. So here, I've got an x squared. Do I have another x anywhere else in this problem? No. So it just stays x squared. There's nothing to change it. Right here, though, I've got y to the 4th. Do I have any other y's?
Yeah.
Yeah, a y to the what?
Third.
What am I going to do with the exponents 4 and 3? Add them. So I'd have y to the, there we go. Okay. All right, let's do another one. Number 6, does the 10 have an exponent? No. Does this 3 have an exponent? No. Does the 2 have an exponent? So what am I going to do with those numbers? Multiply. So what's 10 times 3? 30.
60.
30 times 2 would be, yes, 60.
60xy.
Okay. Now we go back and worry about our variables and their exponents. So this x, does it have an exponent? The first x? Okay, so there's not one written there, then what's it understood to have an exponent of?
1.
1. Very good. All right, so for my x's, this first one has a 1. What does the next x have an exponent of? 1/2. So I'm going to add them, right? And then what does my next x have an exponent of? 2.
How does the x have a 1?
It's understood. Anytime there's not an exponent there, it's understood.
So just like x is.
Yes.
So it'd be 2.
So yes, we have this one has an exponent of 2. This one's got 1. This one's got a 1/2. And like we said, we add them all up, right?
3.5.
Yes. So we do have not 3.5. Yeah, 3.5. But we don't want to write it as the number 3.5.
3.5.
We don't want a decimal either. So we write it as an improper fraction, like this 9/2. Okay. So what I want you to do is in your calculator, I want you to type 1 plus 1/2 or 0.5, whichever you prefer, plus 2. And hit enter. Tell me what it gives you. 3.5. Press map, enter, enter.
7 over
7 over 2. And that's what we want to put in our exponent. So 7 over 2 is what I'm going to have as my exponent. So I have x to the 7 over 2. All right. Now I also have to do this for all my y's. The very first y, what is its exponent? 9 over 2, yes, or 9 seconds. Okay. What does the next y have an exponent of?
7 over 2.
7 over 2. Okay, so these are common denominators, right? I could go ahead and add them as they are. What is 9 plus 7? 16, good. Over that common denominator 2, and 16 divided by 2 is 8. So this one has a nice pretty whole number for us. So I would just have y to the 8th. I do not recommend you trying to add these without your calculator. Just type it in your calculator just to be sure.
So
Okay?
y to the 8th.
Y to the 8th.
We're done.
Yeah, that's the end of the problem. All right. We got another one right here at the bottom. It says find the area in square units of a rectangle that has this width and this length. Okay, so we said to find the perimeter of something, we added up all the sides. Can anybody tell me how you find the area of a rectangle? Length times width. Very good. So area equals length times width.
So would it be parentheses 2x the second power, y the second power, close, and okay.
Very good. So they told us the length was what? Okay, so I'm going to plug that in for L. 4x to the 5th, y to the 1/3, times,
I'll put them back.
it's okay, it works the same way, times the width, which they said was,
2x to the second power.
good. Okay. And now we work it out just like the one up above it. So, my number 4 right here, does it
No.
have an exponent?
No.
No. Does this number 2 have an exponent? No. So what am I going to do with the 4 and 2?
Make it an 8.
Multiply. Yes, we do get 8. All right, then for my variables, I add their exponents, right? So let's start with x. What's the first exponent for x?
2.
5. Yeah, yours is the other way around. And the other one is
7.
2.
7.
All together, yes, would give me 7. So I have x to the
7.
7th power because 5 plus 2 is 7. Okay, now I'm going to do the same thing for my y. What's my first exponent for y? 1/3. Plus, what's my next exponent for y? 2.
7 over 3.
Yes. So remember, we're going to add this in our calculator exactly how it's written here. So 1/3 plus 2. What does the calculator tell you?
7 over 3.
7 over 3. And if this is 7 over 3, then that means I have y to the 7 over 3. So that would be my area. Okay? All right, flip it over onto the back. Okay,
E times B.
here they said to expand this out. B to the 5th means B times itself how many times? 5 times. Okay, so I'm going to write that out.
B times B times B times B times B.
Okay, over, what does B squared mean?
B times B.
B times B. Okay. Remember, whenever we have something in the top of a fraction and the bottom of a fraction, what happens to it if they match?
I cancel.
They cancel out, right? So this B
3.
and this B could cancel out,
So
right?
B to the 3rd.
Yes. And this B and this B could cancel out. So how many B's are we left with in the top there?
38.
3. And did we have any left in the bottom?
Nope.
No. So nothing left in the bottom, just B to the 3rd.
and get this.
All right.
She want to cheat.
On number 9, what am I going to have at the top of my fraction when I
Well,
expand it
It's
out?
the same thing.
B times B. In the denominator, what am I going to have?
B times 5.
Not B times 5. B times itself.
B
5
times B
times.
times B. Yeah, you cancel out.
All right, so yeah, we can cancel out one of these B's with one of these, and one of these with one of these.
B to the third.
Sheeps.
Okay, so this is different because are there any B's left in the top of the fraction? No. So I have to put something up there. So I have to have a placeholder of
So what-
1.
Okay.
Okay, because anything that's divided by itself is just 1, right? So my placeholder is 1. In the bottom, how many B's are left?
Maybe 2.
How many are there? 3.
I don't know if you just use one of those B's up there.
Right. So what could you do with the numbers 5 and 2 to come up with the number 3? What would you do with 5 and 2 to get you 3? You subtract, right. Which leads us to our next rule for the day. Dividing powers, which is what we're doing here, right? Dividing gives us that fraction bar. It says whenever you're dividing, you subtract your exponents. So when we were multiplying on the front page, we added the exponents. Now that I'm dividing, I'm going to subtract the exponents. All right? So let's give that a try. Here, I've got 4 and 3. What am I supposed to do with the 4 and 3 exponents?
Subtract.
Subtract them.
So 3 to the first power.
3 to the first power. And were there more in the top or more in the bottom? More in the top. So my 3 to the 1, or just 3, goes in the top, and your 1 goes in the bottom. Okay? But anything divided by 1 is itself. So this would just be
3 to the first.
3, yes, or 3 to the first. Okay? Same rule here, but this time my exponents are 10 and 3. What am I going to do with 10 and 3?
Subtract.
Subtract. What is 10 minus 3?
7.
7. This time, did I have more in the top or more in the bottom? More in the bottom. So that's where it goes, in the bottom. A to the 7th in the bottom. So what's my placeholder in the top? 1. Okay? So you're always going to subtract them. Just put it wherever there was more.
So wouldn't it just be A to the 7th?
1 over A to the 7th is not the same as A to the 7th over 1. This is like 1 divided by 3 is not the same as 3 divided by 1, right?
So it would be 1.
This is it. This is the answer. That's all we can do. Okay? So right here, you might want to make yourself a little note about what we just said. Whenever we subtract, say, and leave the term where the bigger exponent was. So on the first one, our bigger exponent was in the top, so that's where we put the 3. Here, my bigger exponent was in the bottom, so that's where I put the A to the 7. Okay, let's do a couple more of those. All right, so here on number 10, we only do it for the same letter. So what are my exponents for x? 3 and 2. And what am I supposed to do with them? Subtract. So I've got 3 minus 2, which would be 1. And where was the bigger one at? Top or bottom? Top. So I'm going to put 1x up there in the top. Okay, now I've got to do my y. What are my exponents for y? 5 and 2. And what am I going to do with those two numbers?
Subtract.
Subtract.
3.
I do get 3, and what's the bigger in the top or the bottom? Top. So I'm going to put y to the 3rd in the top, which means it's over 1, right? There was nothing left in the bottom. But dividing by 1, do I really need it? No. So this would just be x, y to the 3rd.
On the
Look
test,
here.
if we put it over 1, will we still get full credit?
Yes. All right, on number 11, I've got big numbers 8 and 2. Did either one of them have an exponent?
No.
No. So I do it like I normally would. I would actually divide the numbers. Yes, 8 divided by 2 is 4. Is the bigger number in the top or the bottom?
Top.
Top, so the 4 goes in the top. Now I worry about my variables. So for m, what were my exponents for m?
5 and 8.
5 and 8, so I'm going to subtract them. What is 8 minus 5?
3.
3.
4 to the third.
And where is it going to go? In the top or in the bottom? This one goes in the bottom. So I'll have m to the third in the bottom of the fraction. Okay? Now we do n. What are my exponents for n?
4 and 7.
4 and 7. And what do I do with those two numbers? Subtract. And what do we get?
3.
3. And do I put it in the top or the bottom?
Bottom.
Bottom. So n
To the third.
to the third in the bottom. And that's it. There's my answer. Okay. All right. Let's do another one. Okay, so look, number 12, not only does it have that division bar, it also has multiplication up in the top, right? So we're going to simplify the top first. So ignore the bottom, let's just do the top. The 6 and the 3, those are big numbers. Do they have exponents? So what do I do with the 6 and 3?
Multiply.
Multiply. What is 6 times 3? 18. Very good. All right, and then my A's. If I'm multiplying, what do I do with their exponents? Add them. So what would I get? A to the 6. And this is all over 2a to the 5 halves. Okay, now we can divide. So 18 and 2. Neither one has an exponent, so what do I do with 18 and 2?
Subtract.
Not subtract. Divide. What is 18 divided by 2? 9. Very good. All right, and then for A, I've got 6 and 5 halves. What am I supposed to do with those two numbers? Subtract. Very good. So 6 minus 5 halves. What is 6 minus 5 halves? Very good. So I'll have A to the 7 over 2 because 6 is bigger than 5 halves, right? So it goes up there in the top. So I didn't have anything left in the bottom. You can put a 1 there if you want, but we don't need it, right? So you could say this is equivalent to 9A to the 7 over 2. All right. Number 13 is just like this one, so we're going to take care of the top first. What do I do with that -3 and +4?
Multiply.
Multiply, which is going to give us, very good. Okay, and then this m and n in the second parenthesis, what are its understood exponents if it's not 1? 1. So this one's a 1, and this one's a 1. Okay, and what do I do with exponents when I multiply? Add them. So I have m to the third and m to the first, which would give me a total of m to the fourth. Good. All right, for n, 2 and 1 gives me n to the third. Very good, yes. Over 3 plus 1.
Oh,
Yeah. And then this is all still over that 6m squared n to the third, right? Okay. What do I do with the -12 and the 6? Divide. And what do we get? -2. Okay. Okay, and remember, I'm not concerned about which one's being negative. 12 is bigger than 6, right? I'm not worried about the negative sign, okay? I'm just looking at the number itself, and 12 is bigger than 6, so it's going to go in the top since 12 is bigger. Okay, then for my m, I've got exponents of 4 and 2. What am I going to do with those? Subtract. And what is 4 minus 2? 2. And is the bigger one in the top or the bottom? Top. So I'll have m squared in the top. All right, then for n, what are my exponents? 3 3 and 3. What is 3 minus 3? 0. So it's completely gone. There's no n anymore. It's all the way gone. There's 0 left of them. Okay, and then I can put this over 1, but I don't need it, right? So I could just say this is negative 2m squared. Okay. Those two divided out for us. All right, last one. This one says that the area of a parallelogram is 36x to the 8, y to the 7. The height of the parallelogram is 9x cubed, y to the 5th. The area of the parallelogram can be found with this formula right here. So they gave you the formula. A equals base times height. And they want you to find the length of the base. All right, so just like our last formula, I just plug in what I know. So do I know what I can plug in for A? Did they give me something for A? Yes. Okay. So I'll have 36x to the 8, y to the 7 equals, do I know B? No. Okay. So B is going to stay B for now because I don't know what it is. Times the height. Do I know that's something I can plug in for H? All right. And I'm trying to solve for B, right? That's my goal here. So B right now is being multiplied by this stuff. What's the opposite of multiplication? Division. So to get rid of all that stuff, I divide by it. Okay? But if I divide one side of my equation by something, got to divide the other side. Very good. So we'd have 9x to the 3rd, y to the 5th over here. So the whole reason we did that over here is so that all of this would go away, right? Now I just need to simplify this side over here. Okay, so what is 36 divided by 9? Four. And 36 is bigger, right? So 4 goes in the top of my fraction. Okay, then for my variable x, what am I going to do with the 8 and the 3? Subtract. And what would I get? 5. And the bigger number was in the top. So x to the 5th in the top. Then for my y's, what am I going to do with my exponents? Subtract again. What do we get? 2. And where does it go? Top. So was there anything left in the bottom? No. You can put a 1 there if you want, but you don't have to have it, right? It's the same thing without it. Good. Good job, guys. So if we're multiplying, we add the exponents. If we're dividing, we subtract the exponents.